All right, good afternoon. How y'all doing? Welcome to the. Oh, that was weak. Come on. Much better. I know it's been a long weekend. You can hear it's been one for me too. Anyway, we're here to talk to you today about the wireless aerial surveillance platform. And what this is a home-built UAV that does Wi-Fi and GSM sniffing and cracking. My name is Mike Tassi. I'm a security consultant. I do all kinds of work for industry and government clients. And this is my partner, Rich.
I'm Rich Perkins. I'm a computer security engineer working as a contractor for the DoD, amateur radio operator, and RC hobbyist.
Use the mic.
Mike's got to get closer to me.
I am closer to you. All right, so we'll get serious here. We're going to talk to you first a little bit about what the plane is, how we built it, some of the component parts, and what our idea behind the system was. And we'll start out with how it came to be. About a year and a half ago, it was about October of 2009, I saw a Hackaday article about a guy who had built his own DIY first-person view RC plane, and I thought that was really cool. I got to do that. I could think of all kinds of evil stuff to do. So I called Rich and I said, dude, I got an idea.
From experience, that's not a good thing. It usually means I won't be sleeping at all for the very near future. He showed me these videos, first-person flight of RC aircraft, and I thought it was a really cool idea. But being the warranty voider that I am, I thought, well, what else could we do with it? If we're going to put some money into an airplane and try to do cool stuff with it, let's start off with maybe putting Kismet on board and try to do a little bit of war flying. Maybe that'd be kind of cool. That very quickly turned into, well, if we're going to put the horsepower to run Kismet, we might as well just beef it up a little bit, and let's put Backtrack 5 on board, have a full penetration testing suite available to leverage against Wi-Fi and the various targets that might be acquired on there.
So now that we had a flying hacking robot idea, we decided that we probably ought to sort of size this, because we figured the hardware is going to be heavy, and RC stuff, you really don't want to start out too small. So we cogitated a little bit on what we were going to need, and we came up with the idea that we could probably do somewhere in the neighborhood of an hour's worth of runtime, and that would give us enough time to do passive stuff, sniff Wi-Fi, do the war driving, war flying thing. And it would give us enough time that once we got information that we could use, we could actually do some kind of usable attacks in that amount of time. So we strive to get an hour out of it. We got most of the way there. If you strip it down, it gets right there. But we're doing about 30 to 45 minutes. And that's affordable from an RC perspective, and it gives us enough time to do what we need. The second consideration was that we really didn't want to have to use a forklift because it's really inconvenient and you can't drive them on the roads. So we needed to keep it really small, and so we searched for sort of an airframe that would allow us to take it out to the field ourselves and fly it and use it and retrieve it without too much trouble.
So now that we got basic kind of requirements of what we wanted to build, we decided we needed a reason why. I'm not sure why we needed that, but we decided that just because wasn't really enough. And what we wanted to do is we wanted to go out of our way to use open source off-the-shelf components, get stuff that basically anybody in this room can mail order, glue it together, and rebuild what we've built. So we kept a few things in mind when we were designing this. We wanted low cost, open source, off-the-shelf components, and really focus on building the airplane. We get a lot of questions like, well, why didn't you use this hacking penetration suite, or why didn't you run your own custom Linux kernel? Because I wanted to build an airplane, not compile code and have a custom role your own that no one else can duplicate. I want you guys to take what we've done and go further with it.
So now we kind of had a point to the project, and that was as we started to realize that all these open source communities and tools and things that are available now that weren't available a few years ago could be brought together. We thought everybody could do it, and the idea was rather than, like Rich said, spend all day rolling our own stuff that was unique just so we could call ourselves elite. We would go out and get all the stuff that we can find on the internet and kind of put it together. The focus was on integrating all of those components together and making them work versus designing our own and making it impossible. The focus was we wanted it to be repeatable by everybody. The maker community can take it and go do cool things with it and turn it into a camera drone or put new tools on it as things come available. Some of the talks here have provided us with a lot of fodder for next year's model. So, with that said.
So, great. What is this thing that you're looking at here? I mean, it's bright yellow and got googly eyes. How evil can it be? Let's talk a little bit about what it is that makes it up. And to start off, we're going to start with the airframe.
So the airframe we originally started with was a much smaller model. It was an Easy Star, and we thought, and that was what the autopilot was originally intended for. But we quickly found out that airframe was way too small to be lugging the kind of batteries and the kind of hardware that we were going to need. So we went searching for another one, something that was big enough and strong enough and was going to be tough enough for the learning phase, obviously, that was to come, because neither one of us are very adept pilots. So we settled on an old U.S. Army target gunnery drone. It was called the FQM-117B. It was made to look like a MiG fighter, and soldiers would fly these things around, and other soldiers would shoot at them to practice their gunnery skills. And they lasted a few years, and then they sort of decided they were going to move on to something else, and they surplused all of these things. You can still find them online on eBay and at RC modeler shops. They're pretty popular with those guys. There were, for a couple of reasons, we went with this. First, Rich had one already, and it was free, so we were going to save a little money there. And that was originally, I'll have to admit, our first attractive quality of this airframe. But after that, we started to realize that it really was a good choice for us. It's made out of foam. It's very sturdy. It also has aluminum reinforcement rods from the front to the back and across the wing, so it can lift a lot of weight and it can take a lot of crashes, which, take it from me, if you decide to do research in this area, those are two things you're going to be very used to, is adding weight to your airframe and picking up pieces of your airframe, because you will crash a lot. We're currently lifting 14 pounds, is what our aircraft weighs with all the stuff in it. And supposedly, I've heard rumors from the guy who originally designed these things that they would fly at 20 pounds. We have gotten nowhere near that, but 14 it flies just fine. And let Rich talk to you about the powertrain.
So now that we've got an airframe, we needed to get this thing in the air. It was the original design called for a 60 size nitromethane RC hobby grade motor in it. Really, really loud, really, really noisy, and really messy with castor oil as a lubricant. So we opted to convert it to electric. We've got an E-Flight 90 brushless outrunner motor. It pushes about 2.5 horsepower for a 17 by 10 inch electric prop. And all of that's powered by dual 6-cell 22.2 volt, 5,000 milliamp hour LiPo batteries. About 30 to 45 minutes of runtime. 60 if we push it. So let's talk about the avionics. The avionics bay is located on the left side of the aircraft. Mike's going to point it out to you. So what this is this starts off as your typical RC hobby or radio control hobby grade components. We've got a JR Spectrum DX 6i transmitter and receiver pair for doing manual takeoff, manual landing. In addition to that, we have a DIY Drones ArduPilot, the first generation of ArduPilot. That's our autopilot that allows the airplane to fly autonomously. Connected to that is the Ardu Shield, which is the interface between the ArduPilot and the X, Y, and Z infrared sensors. These are the thermal piles that allow the airplane to sense the temperature difference between the sky and the ground and determine where it's at in 3D space. That's all in line between the RC equipment and the various servos. These are the actuators that control the various control surfaces, the rudder, the elevator, the motor. And connected to the ArduPilot is an XB Pro with an Adafruit adapter on 900 megahertz. That's our telemetry downlink. That's really handy when it crashes. We know where the plane's at to go pick up the pieces. It also gives us in-flight information, battery voltage, pitch, yaw, roll, airspeed, etc.
Oh, I guess it's my turn. The payload. This is the fun stuff. Our payload computer is basically, it's two subsystems. The first is basically that computer bay on the left side that you see hanging out next to the avionics, and that has the actual processor and computing components in it. And if you notice in the picture, you'll see down inside there's also some USB hubs and a wireless LAN card. And the GPS for the payload computer. The second component is, of course, the Edis Research USRP version 1, which we use for the IMSI catcher and GSM capabilities. Now the details. The computer itself, what it's actually being run by is a VIA EPIA, in this particular case, a Pico ITX motherboard. I think this slide was made before last week's critical hardware failure in which we swapped the motherboard for a faster one. But right now it's a 1 gigahertz VSE7. It's got a gig of RAM. It's got a 32 gigabyte Voyager GTR flash drive, which we use Backtrack 5 on. All stuff that you can get either online or at the store. On board, we also have, and it's not on this slide because we're terrible at this, an Alpha Networks AWUS 036H, the 1 watt card. It's a RTL 8187 driver. Very cool, works with Backtrack, and is very slim and fits in the inside of the bay on the left side at the bottom. In addition to that, we have a T-Mobile USB 4G dongle for our cellular broadband connection. That's how we get all of our data off the airplane to the internet or across the VPN to our back-end systems, and how we would route voice off in the case of using the IMSI catcher. In addition, you'll also notice another antenna over there. That's an additional XB Pro 900 megahertz card, which is connected to our base station, and we pop a PPP tunnel across that serial link to control our payload computer from the wireless access point down in our base station. That's how we control it in local mode. We can also do the same thing across the 4G dongle using our OpenVPN. The last thing we'll talk about is the Universal Software Radio Peripheral. This is basically Edis Research's software-defined radio. We use it in combination with GNU Radio and OpenBTS to provide us the capability to middle cell phones, attract GSM cell phones over, spoof a base station for a GSM provider in the States or other places, and then route phone calls across our 4G dongle out to the internet and the PSTN.
So the base station, that's this little yellow box. I don't know if the folks on the other side can see the box, Mike, if you want to hold it up for a second.
Absolutely. Where's my manners?
This base station, it's a little box we built. It has a Gumstick Severa Earth with an ARM Cortex A8 600 megahertz processor. Chestnut 43 add-on board that gives us our USB connectivity and Ethernet connectivity, as well as the nice 4.3-inch touchscreen display. Connected to that via USB is an XB Pro 900 megahertz. That's the PPP tunnel. That's the sister to the one on board the payload computer. That allows us to connect from the payload, from the ground, or from the base station from the ground up to the payload and control Backtrack 5, leverage the tools that are on board. It also has a DIY Drones Ardu station. That's the green LCD at the top. That's also connected to the Ardu station. That's our telemetry data, that's the GPS. That's what we use walking around with when we lose the airplane in a cornfield somewhere. We can find it with this. Inside this box is also an ASUS access point. This allows any of your laptops, tablets, cell phones to access the Wi-Fi access point and connect directly to the payload computer via a terminal emulator and use the tools as you see fit. Those of you in the front row will actually, those of you that are reasonably close, it's a very low power access point. There is an access point called WASP base station. Like Mike said, please wait till afterwards to start DOSing us. So we've got an airplane. But that's not all. We also have a back-end server that we've put together with an Intel P4 36 gigahertz processor, 4 gigs of memory, 500 gigabyte hard drive, and an NVIDIA GTX 470 utilizing the Compute Unified Device Architecture, or CUDA, for brute forcing hashes, computational values, what have you. We've paired that with a software package called Pirate, and we're able to do 19,300 pairwise master keys, or PMKs a second, for brute forcing WPA four-way handshakes. This server also functions as our Asterisk backhaul for the mind blank. The IMSI catcher, the USRP IMSI catcher that's on board the plane. The dictionary that we're currently using that we have available, we've scoured the web for 1,000 most commonly used passwords, etc. We have a 4 gigabyte dictionary, 354 million entries. We can process that dictionary against the WPA handshake in about 4.5 hours. This is really small time hardware stuff. They've got benchmarks out there of 280,000 PMKs a second. That would chew through our dictionary in about 18 minutes. This back-end server also functions as our OpenVPN server. This is where all our clients connect. The airplane connects to it. Anybody with the OpenVPN certs can connect to this server and then thereby get direct access to the onboard payload of the aircraft when it's in flight. So that's great. We got all this technical mumbo-jumbo hardware stuff. What exactly can we do with it?
Yes. So what I'm going to do now is kind of walk you through our system layout, the system topology, and how it's supposed to work. We're going to start out with our clients, or our victims rather, as indicated by these cutesy little access point, cell phone, and Bluetooth dongle. And with any victims, you have to have attackers, so we have a couple of attackers down there. And these guys really want to attack these devices, so they're trying to figure out how to do it. They can't do it. They're too far away. It exists in another, behind a fence. It's Area 51, whatever you want to call the scenario. So they call in their airplane because it's really hard to stop an airplane, and it doesn't sit in the parking lot. So the airplane has all of its onboard wireless capabilities, but without a way to talk to the attackers, they're kind of stuck with passive attacks, war flying, that sort of stuff. Anything you can automate, but there really isn't a lot of flexibility there. So what the attackers need to do is talk to the airplane. In order to do that, they need to know a couple of things. First, we needed to create a base station so that they could get this data from the airplane and send data to the airplane. The first data stream that they're interested in is, of course, telemetry. We get our telemetry down across the XB900, and it tells us where the airplane is, what its attitude is, what its geolocation is, so that we know, we're either out in the middle of the desert or are we over the hangar at Area 51 or whatever the case may be. In addition to that, the airplane also needs to give us a downlink so that we can get our PPP connection to it, and the attackers can now actually use the tools on board the airplane interactively to go after the clients, so they're not relying on automated tools and passive stuff. So this system, as you see now, it works okay. It'll work for web cracking or little stuff. But it really would be cool if we could do something a little more, so we say, demanding. Things that require lots of computational power, that sort of stuff. We can't fit it on the airplane because there's just simply not enough room for the weight that we would need to put big cards and big processors and that sort of thing in the airplane. What we need to do that is back-end systems, and that's what Rich just defined was what our back-end system consists of, and the only way we can get there, of course, is across the internet. So in order to do that, we've introduced the 4G dongle on the plane that gives us a pretty big pipe back and forth, of course, anywhere there's cell signal, and allows us to create a VPN across the internet to our back-end systems. And that provides us with two things. It provides us that extra horsepower that we need for mathematically computational intensive functions, and it also allows us to do things like pop up a fake access point and pretend to be a Starbucks in the sky and route everyone else across the internet in the middle of the connections. So what we did to kind of make things a little bit easier, we've scripted a lot of tools to kind of sort of automate some of the offload capabilities. So when we're sniffing, say, a WPA handshake, that capture file is then wrapped up in a script and sent to the back-end station. And I'll let Rich get into the details of that.
Yeah, we've kind of dubbed it the glue script. It's really the only piece of code we wrote for this entire system. There's two pieces to the code. There's a small bash script that runs on the airplane, does nothing more than monitor a directory. And when it finds a file in that directory, it SCPs it via SSH back to the back-end system for processing. The back-end system has the other side of the script. It monitors an incoming directory. Based on the file attachment that comes into that directory, the script knows how to process it. One of the first things that it can do is if you send it a capture file, it will automatically launch the pirate to do brute forcing of the WPA handshake using our dictionary. And then it emails you the results onto your phone. So you're about 3-4 hours later, you get an email with the passphrase or the key. The second thing that it can do is I really wanted to, our guys have a limited time on target because we got 30-45 minutes of flight time. So if you know the target, you can create a custom dictionary, children's names, birthdays, etc. Build a custom dictionary file, pass that along with the four-way handshake, and it'll process it using that dictionary instead of the big dictionary. Send you the results much faster, usually 15-20 minutes you can get a result. Then, of course, it takes that custom dictionary and incorporates it in the master dictionary, so we've always got those entries available to us. It really saves a lot of time as, when you're on target, you just take the capture file, you shove it into the directory, and you forget about it. You go do what else you're going to need, and about an hour or so later, it emails you back the results. Usually about the time the batteries are charged, you're ready to go do it again.
So another neat thing that this OpenVPN architecture gives us is the ability to allow sort of distributed groups of hackers to come through one sort of choke point. Your airplane is your weapon. It's your single point of attack. And because we have the OpenVPN capability, that means if I've got a buddy in Japan that has some really cool ODE for an app that I haven't seen before, I can just call him up and have him log on to the airplane from the other side of the planet and direct some attacks at a corner store on the other side of the world. So it really kind of gives us some flexibility to allow us to bring other people into the fray. Very cool stuff. So, yes. Because we're going to be moving all this data around, one of our concerns was even the bad guys are worried about security. Some of this data is going to be sensitive that comes across. One, you don't want them to know what is going on, and secondly, you might want to protect your data. So all of our hardware and software connections are AES encrypted. The XBs via hardware and the OpenVPN, of course, via software. The telemetry as well.
It's hardware encrypted on the XBs. They have built-in 128 AES encryption. So what you're looking at here is actually, at the very center is Caesar's Palace. This is an RF propagation map for both the 900 megahertz GSM and the 2.4 gigahertz Wi-Fi connection. The yellow area in the middle, it's about 1,500 feet across, basically covers the entire Caesar's Palace campus. This is where we can reliably connect. The green area, that's ward driving territory. We can get data, but we may not be able to connect. So you can see just from 400 feet up, we get a really big footprint, and we can easily turn this airplane around and have it circle within 250 feet, so we can keep it on target really, really well. Movie time.
Oh, yeah. I love movie time. Popcorn.
This was a triumph. Success. It's hard to for the good of all of us, except the ones who are dead. But there's no sense crying over every mistake. You just keep on trying till you run out of faith. And the science gets done, and you make a neat plan for the people who are still alive. I'm not even
that's what you'd see from the ground.
I was so happy for you. Now these points of data make a beautiful line, and we're out of data, we're releasing on time. So I'm glad I got burned. Think of all the things we learned for the people who are still alive. Go ahead and leave me. I think I prefer to stay inside. Maybe you'll find someone else to help you. Maybe Black Mesa. That was a joke. Haha, that chance. Anyway, this cake is great. It's so delicious and moist. Look at me still talking when there's science to do. When I look up there, it makes me glad I'm not you. I've experiments to run. There is research to be done on the people who are still alive. And believe me, I am still alive. I'm doing science and I'm still alive. I feel fantastic and I'm still alive. While you're dying, I'll be still alive. And when you're dead, I will be still alive. Still alive. Still alive.
So I don't know if any of you noticed the little dot on the when it was rolling out on its final approach. That was a C5 Galaxy. They looked about the same size. So that was a flight for our flight control systems. Our new rudder and tail. Apologize for my voice. It's really hard. So anyway, during that flight, we captured something like 50 different access points from that cornfield. So it works pretty well. So now we'll move on to some demos of what we're doing inside. First, the base station, which of course I held up earlier. That's provides telemetry and a Wi-Fi access point for all of your crew on the ground to work through the airplane. We could do it on the tablet. Yeah, if you could.
Can you all see? It's pretty small. Where's your Connect bot at? Or terminal emulator?
There you go.
Here, you do it. It's your tablet. You do it.
All right.
I'll talk about the aero dump. So if the monitor is still active over there, it's not gone to sleep. That's aero dump. We started it off when we started the talk. We plugged the monitor into the payload so you could actually see it gathering Wi-Fi. The antenna's pointed that way, so using the front row won't have to worry about any side effects of strong Wi-Fi signals penetrating your brain. I can't see what we've got on there right now, but at last count there was about 100 or so access points that were showing up just from the stage. We have access to run Kismet, aero dump, aero crack, so we can set up a fake access point, fly over Starbucks, free public Wi-Fi, connect to me. We have the entire Backtrack 5 payload, so we can do whatever you want. You want Metasploit? We got it. We can use it against clients. We can attach to them, do whatever you need to. Mike's connecting to, he's going to log into the airplane. It'll be kind of hard to see, but we're actually using a Motorola Zoom connected to the base station using, what do you got, better terminal emulator? To connect to the payload so that you could manipulate the tools with using an Android phone, a tablet, a netbook, your laptop, anything that you can put a terminal on, you can connect to the airplane with. Makes it very convenient, easy to use, less hardware to haul around.
I would, except the base station appears to be very, very busy right now.
Strange. I don't think they're going to be able to see much anyway on that little tablet screen. So we'll move on to the, let's go ahead and move on to the USRP. Is that monitor still up?
Yeah.
Oh, look at all the Wi-Fi.
Yes. All right, so we'd love to turn on the USRP in here and snag phones, but we haven't put up any warning signs, and we really don't want to destroy our system like Chris did with his thumb drive last year, so we thought maybe a slide would be more appropriate. This is, of course, our terminal on the airplane. As you can see, it's OpenBTS running, and there in the middle, the output of TIMSys is showing a connection to what is actually my little Sony Ericsson phone with the 310, 410 of AT&T, clearly indicating my ponage. What we would do is fly that around. People's phones would connect. We would pass their connections off to our PBX that would be automatically configured or provisioned for our PBX, and then ship their data off over a SIP backhaul to wherever its actual destination would be. In that case, hopefully the victims would never know that they would be owned. Their telephone calls would be clear text, and we would be able to read their SMS. I will say a couple of things about this. It doesn't work for incoming calls, of course, and also data connections, something that will also not work across the airplane. But for phone calls and SMS, it works very well. This is your territory.
So you're probably sitting there thinking, well, that's pretty cool, but what's this going to cost me to put together? Keep in mind that when we go through these costs, these are very boring because it's just numbers and blah, blah, blah. You don't have to build what we build. This is actually pretty expensive. Relatively cheap compared to, say, I don't know, a Predator, though. So, airframe, as we stated before, it was sitting in my basement collecting dust. It was free. Free is good. You can actually buy this airframe online through, I think, eBay. Some of the RC groups online have them for sale. They typically run in the $150 to $200 range for just the styrofoam. The payload, about $640 for the Via Appia, the various Wi-Fi card, the GPS, and the various components, USB hubs that went into that. The USRP was the single most expensive piece at $1,600 for the main board, the two daughter boards, RFX 900 daughter boards, and then the clock tamer so that we could have a stable 52 megahertz clock and grab phones more reliably. The avionics portion, the JR, the RG Pilot, all of that stuff, that's about another $800. The power plant, the motor, the two battery packs that we run, and the speed controller, another $800. The base station, Gumstick Sovero Earth setup was $350. The RG station was about $100. Wi-Fi access point, $50. 7-port USB hub and a project box, another $50. Like I said, this is boring stuff. Back-end PC, your typical generic x86 PC, about $600. When we bought the video card, the GTX 470, they were running right around $300. So 5960, we added an additional $500 for things like bolts, wire, screws, glue, paint, various other things. So we're sitting right about $6,200. That's not counting the mistakes that we had. There were a few. I let the magic smoke out of some stuff. I lost count, actually, how many times the smoke came out. So, lessons learned. Mistakes cost money. You can save some if you use some of our mistakes and don't repeat them.
God, I wish he was shorter. All right. We're going to go over some of the stuff that we learned during this project to help some of you who may be wanting to do something similar. It's really important that you don't say, I'm going to build it on this airframe and then try to cram all of the things that you come up with into that airframe. You sort of want to do it in the reverse order. You want to figure out what you want to do first and then find an airplane that'll fit what you want to do in it. That'll save you a lot of time and a lot of money. wasted trying to figure out how to fit things that won't get any smaller into spaces that won't get any bigger. So remember to make the right choice up front, design your system's internals first, and then wrap them in an airplane. Secondly, just like with anything else, don't expect to be great at it when you start. Neither one of us was an aircraft guy. RC helicopters, off and on. I wouldn't even call myself good at that. You're going to crash a lot. You're going to do what, in retrospect, you will think are stupid things, but you're going to learn a lot from them. So don't get depressed when you're picking up styrofoam. It will happen, and probably a lot. Some of the things to kind of give you an idea of how this went, some of our good and bad decisions. We chose the MiG after thinking about it quite a while and decided that we weren't going to purchase the Easy Star. And that was a good decision because had we decided to spend the money on the Easy Star, it would have been a lot of time spent trying to alter what we wanted to do to make it fit the airplane. At the time when we built this, there were not a lot of easily attainable ARM distributions, and since we didn't want to roll our own anything, we elected to stay away from gumsticks and that sort of thing for the internals on the airplane. And so we decided to go with the VIA. And that was, it seemed like a good idea at first, but in retrospect, it's been a little bit iffy. Probably not a good idea to buy the first generation of anything, and the boards have turned out to be a little bit unstable. We did yeah. Somebody have a question? Oh. Propeller size, we originally had no idea what we were doing. We're both really bad at math, and we thought that this tiny little propeller was going to be more than enough to fly this 14-pound behemoth. After a nice hammerhead stall and a lawn dart impression, we learned that perhaps we should get with some folks who actually know what they're doing to size this properly. And so we learned our first very important lesson, and that was that there's a lot of communities out there that are really good at what they do, and they really like to share. So if you have any questions, just ask them, especially around things like the legality of flying UAVs in your area. Check with your local flying clubs and see if you can't get some support from them, because they're really cool people. I know the ones that we dealt with in Illinois are fantastic, and they helped us out tremendously. So leverage all these communities. Also, the altitude sensor location or the attitude sensor location. Yes, we had a couple of problems. You'll notice on the tip of the tail that there's a little black spot and a notch that's cut there. And once again, hindsight is 20/20, but originally that was our location for the thermopile sensors. And they need a clear view of the horizon, and when both of those saddlebags are put in place, they have a clear view of both XB900 antennas, which really make the airplane think that it's going, that it needs to dive. So after a little bit of work, we decided that the belly was a much better place to put those sensors. So,
Can we talk for a minute?
Yeah.
Just give your voice. I don't have any water. So this has no custom parts. We didn't custom build anything. We just mail ordered stuff offline. Via Appia, we've got a USRP, we've got the DIY drones RG Pilot, XBs from SparkFun. This is all mail order. You guys can build this easily. You just have to have some, motivation to get started and learn this stuff. And we did that intentionally. Everything that we've done is on our website. It's GPL. Take it, ask us questions. We'll be more than happy to, kind of give you more information or maybe steer you in the wrong direction if it's a mistake, but that happens, I guess. This is what we came up with. Go forth, take this, build better things, make us look bad. It's awesome. Something to consider though. There's a lot of open source communities out there. They do great things. You're not going to be popular because you're going outside of their world and you're trying to bring multiple worlds together. People are going to automatically assume that you're an evil hacker and you're going to try to destroy their world, their hobby for the rest of them, and they want you to keep quiet. No, never. I mean, we literally received threats that we were going to have the FAA, the FBI, the Army, the Air Force. Everybody. I mean, everybody under the sun, right down to the point of, do your mothers know what you're doing? So realize that when you get into this, that this may not make you the most popular person on the planet. Anything to add? So the reality of it all, it's never really as hard as it seems at first, but it's never as easy as it looks. Be prepared for some trials and tribulations. Unforeseen issues are going to take up time. You don't do what we did and start doing stuff 2 months before a con and expect to get it done. You will crash. We don't learn from success, we learn from mistakes. So pick up your pieces, figure out what you did wrong, and carry on from there. And most importantly, cheap is a relative term.
We're really short on time.
Oh, okay.
So here's some of the links that we used. They have good information, places that you can find some of the things that we used. It's going to be in our slide deck. It's available on the DEFCON site. So go and check it out. You might find some resources that are going to be helpful for you in your research. We'd like to thank a couple of people. Dave Farquhar, he's the guy that actually speaks English and turns what we say into things that everyone else can understand. We'd also like to thank our significant others. We've spent a lot of time sitting in the garage playing with our toys. And because of the fact that we have such loving and supportive significant others, we were able to complete the projects. We wanted to say thanks to them as well. At this time, I don't know how much time we have left, but if you have any questions, I'd be more than happy. So I guess we have 5 minutes. So you're going to take... Okay.